Welcome to This Explainer. Today, we are pulling back the curtain on the massive, completely unseen systems that hold, well, essentially all of the world's digital information. I mean, think about it. Every single time you swipe a credit card, like a post, or book a flight, it all relies on the precise, hidden architecture of a database. We're going to break down exactly how these digital fortresses are designed right from the ground up. Now, 45. That is the number of hours in a deeply dense, super rigorous academic curriculum on database system architecture. But don't worry, our goal today is to distill all of those heavy computer science concepts down into a single, cohesive architectural blueprint for you. We're zeroing in on just the absolute essentials you actually need to understand. Okay, let's dive into this. Here's our roadmap. We're going to cover the architectural foundation, the language and design of data, physical storage and transaction rules, securing the database, and finally, warehousing and data mining.
All right, let's kick things off with Module 1, the architectural foundation. This is a massive 9-hour foundational phase.
So the core goal here is establishing data abstraction and data independence, which basically just ensures that how you, the user, interact with the data isn't completely rigidly tied down by how the computer actually physically stores it. But, before data can even be used, it's got to be modeled. So are you going to organize it like a web of connections, a network model? Or maybe as distinct interconnected items, like an object-oriented model, or a relational model? You really have to lock your data into one of these foundational structures with strict rules, just to make sure it stays accurate and reliable. To actually build and use that foundation, the system relies on two distinct languages. First up, we've got Data Definition Language, or DDL. Think of DDL as the architectural frame, right? It strictly defines the actual structure of our database house. Then, on the flip side, we have Data Manipulation Language, or DML. Once that structural house is built using DDL, DML steps in to provide the specific operations to actually manipulate the data that's living inside it. Moving right along to Module 2, the language and design of data. This is a massive 15-hour deep dive into querying and organizing all that information. Now, evaluating queries actually relies on some pretty intense underlying mathematics. We're talking things like relational algebra and domain relational calculus. Sounds complex, right? But in plain English, it's basically just a mathematical engine that acts like a hyper-efficient librarian, figuring out the absolute fastest possible route to get you your answers. It takes these abstract requests and completely optimizes the strategy to fetch that data using advanced languages like SQL3. So how does this actually look in the real world? Well, these theoretical queries need a home, and that is where database management systems come in. We've got open source options like MySQL, alongside commercial giants like Oracle, DB2, and SQL Server. These are the actual software environments that are powering everything from your mobile banking app to your favorite social media feeds. This is exactly where all that mathematical theory actually operates. But designing all of this, it is definitely not a free-for-all. It's more like a relational design quest. We literally move step by step from first normal form all the way down to the highly complex sixth normal form. And the ultimate goal here? Absolute, perfect organization, where zero data is ever duplicated or lost. It's just a relentless pursuit of efficiency, making sure that every single piece of information has one precise, totally logical place to live. Okay, on to Module 3, physical storage and transaction rules. This covers 10 hours dedicated entirely to the physical basement of our data. Down in that basement, we use storage strategies like indices, B-trees, and hashing to actually organize the data on a physical drive. You can think of these as the ultimate library card catalogs. Without them, trying to find a single piece of information on a massive drive would literally be like searching for a needle in a giant digital haystack. They are the essential mechanisms that allow the system to rapidly pinpoint exactly what you're looking for in fractions of a second. And this brilliantly illustrates our next major hurdle, which is live transaction processing. In any solid database, transactions have got to follow the ACID property. That means they must be atomic, consistent, isolated, and durable. Basically, it's a strict all-or-nothing rule. Like if you transfer money, the system guarantees the money leaves your account and arrives in the other, or the entire action is just canceled. There are absolutely no partial failures allowed here. To enforce those strict rules, the system uses concurrency control and serializability. Imagine, say, thousands of people trying to buy a concert ticket at the exact same millisecond. Absolute chaos, right? Well, these scheduling rules perfectly sequence all those actions, using locks and timestamps to ensure that multiple people can access the system at once without totally crashing it, all while always allowing for full database recovery if something actually does go wrong.
Next is Module 4, Securing the Database. This is a crucial 7-hour phase dedicated entirely to protection.
The crucial takeaway here is understanding exactly how this multi-layered security operates. Because security happens in very distinct layers. First, proving exactly who you are. That's authentication. But just because we know who you are doesn't mean you can go touching everything. That is where authorization and access control come in. It's kind of like swiping your badge to get through the front door of an office building doesn't automatically give you the combination to the inner vault, right? Same exact principle here. And finally, we arrive at Module 5, Warehousing and Data Mining, the last 4 hours of our blueprint. This is the point where traditional databases scale up exponentially into massive data warehouses. Literally everything we just spent time building culminates right here. It's how huge organizations mine for hidden patterns and extract high-level insights. In fact, this is the exact underlying tech that allows streaming services to predict exactly what show you're going to want to binge watch next. It turns raw storage into actual actionable intelligence. But, this syllabus actually ends on a bit of an ominous note. With all of this massive expansion in data mining and warehousing, is your system actually safe from a SQL injection? Could a simple, menacing string of malicious code just completely bypass all of the brilliant 45-hour theoretical fortresses we just spent so much time building? Definitely something to think about as you navigate the digital world.